Right now, without you doing anything, your phone knows where you are on the entire planet, usually within a few feet. You open a map, and a little blue dot appears exactly where you're standing. You never think about it. But that blue dot is the end of something almost unbelievable. To place it, your phone is quietly listening to satellites orbiting 12,000 miles above your head, reading the time off atomic clocks in space, and using the speed of light to measure how far away each one is. Your phone isn't looking at the ground to find you. It's doing physics with space at the speed of light. So let's follow it, from the satellites overhead down to the dot on your screen, step by step. By the end, that blue dot is going to feel like a small miracle. It starts with a ring of satellites you can't see, circling the Earth around the clock. High above you, roughly 12,000 miles up, there's a constellation of navigation satellites, about 30 in the core American GPS system alone, arranged so that, from almost anywhere on Earth, several are always somewhere in your sky. They aren't parked over one spot. Each races around the planet, completing a full orbit about twice a day. And these aren't ordinary satellites. The most important thing on board each one is a clock. Not a normal clock, but an atomic clock, one of the most precise timekeeping devices humans have ever built, accurate to billionths of a second. That's the simplest way to picture a GPS satellite, a flying, incredibly accurate clock in a very well-known orbit, shouting the time. Because as you're about to see, this entire system is really a trick built almost entirely out of time. So what does each satellite actually sing? Over and over, every satellite broadcasts a simple radio message toward Earth, and that message contains two things. First, the exact time the signal left the satellite, straight from that atomic clock. Second, exactly where the satellite was in its orbit at that moment, its precise position in space. That's it. A timestamp and a location, sent continuously, raining down over the whole planet. Any device with the right receiver, and your phone has one built in, can listen for free. Nobody has to talk back. The satellites just keep announcing, "This is where I am, and this is exactly what time it is right now," again and again, forever. Which raises the real question, how does a timestamp and a position turn into a dot on your map? The answer comes down to a race. When that message reaches your phone, here's what your phone does with it. It reads the timestamp, the instant the signal left the satellite, and compares it to the time the signal actually arrived. The difference is tiny. The signal is a radio wave, so it travels at the speed of light, about 300,000 kilometers every second. From 12,000 miles up, the whole trip takes only around a 15th of a second. But your phone can measure that tiny delay. And once you know how long the signal traveled, and you know it moved at the speed of light, you multiply the two and get one number, the distance. Your phone now knows exactly how far it is from that one satellite. One, though, isn't enough. Knowing you're a certain distance from a single satellite only tells you you're somewhere on a giant invisible sphere around it, anywhere on that entire bubble. So your phone doesn't listen to one, it listens to several at once. For a solid position, it needs at least 4. Why exactly 4? That's where it all comes together. This is the heart of it. The trick is called trilateration, and people often call it triangulation, but it isn't about angles at all. It's about distances and overlapping spheres. Picture it. One satellite puts you somewhere on a huge sphere around it. A second satellite gives you a second sphere, and 2 spheres only overlap along a ring. You've gone from a whole bubble down to a circle. Add a third sphere, and that circle shrinks to just 2 possible points. One of them is usually way out in space or somewhere absurd, so it's easy to throw away. You're left with a single spot on Earth, so 3 distances can pin you down. But there's a catch, and it's the reason your phone needs 4. Measuring these distances depends on comparing time incredibly precisely, and while the satellites carry flawless atomic clocks, your phone does not. Its little clock is slightly off, and even a tiny error, multiplied by the speed of light, would throw your position off by miles. The 4th satellite fixes that. With a 4th distance, your phone has enough to solve for its own clock error at the same time as it solves for your position, correcting its cheap clock against the atomic clocks in orbit on the fly. 4 satellites, 3 to place you in space, and 1 to fix time itself. That's the whole miracle right there. Your phone finds you by listening to 4 flying clocks and letting their spheres overlap on exactly 1 point, the ground beneath your feet. Now that word, atomic, is doing an enormous amount of work. And here's where the story gets genuinely strange. The entire system lives or dies on time. Remember, the signal moves at the speed of light, so a timing error of just 1/1,000,000th of a second becomes a position error of about 300 meters. To get you within a few feet, the clocks have to be almost perfect, which is why every satellite carries an atomic clock, checked and corrected constantly from the ground. But there's a twist that Einstein predicted a century ago, and GPS has to correct for it every single day. According to relativity, time doesn't tick at the same rate everywhere. The satellites move fast, thousands of miles an hour, and by special relativity, motion makes their clocks run slow, losing about 7/1,000,000ths of a second a day. At the same time, they're high up in weaker gravity, and by general relativity, weaker gravity makes clocks run fast, gaining about 45/1,000,000ths of a second a day. Put those together, and a satellite clock runs roughly 38/1,000,000ths of a second fast every day compared to one on the ground. That sounds impossibly tiny, but remember the speed of light. Left uncorrected, that drift would push your position off by around 10 kilometers a day. Your maps would be useless within minutes. So engineers build Einstein's correction directly into the system, tuning the satellite clocks so that once they're in orbit, they tick in step with Earth. Your blue dot is accurate because a system in space is quietly accounting for the fact that time itself runs differently up there. There's one last piece. The reason all of this happens in a second or two instead of making you stand and wait. If your phone had to figure this out entirely on its own, it would be slow. The satellite's orbital details come down in that radio message as a trickle of data, and downloading enough directly from space can take up to a minute. That awkward wait some old GPS units had before they found you. Your phone almost never makes you wait that long, thanks to a shortcut called assisted GPS. Your phone is also on the internet through cell towers and Wi-Fi. So instead of waiting on the slow trickle from space, it downloads the satellite's current orbital data instantly from a server over that fast connection and uses nearby cell towers to make a rough first guess at where you are, so it knows which satellites should be overhead. With that head start, it locks onto the real signals and solves for your position in a couple of seconds. So the space part gives you the precision, the atomic clocks, the trilateration, the few feet accuracy. The internet part gives you the speed. Together, they're why the blue dot appears almost the instant you open the map. So here's the whole thing, start to finish. About 30 satellites circle the Earth 12,000 miles up, each a flying atomic clock, constantly broadcasting the exact time and its exact position. Your phone listens to at least 4. For each, it measures how long the signal took, multiplies by the speed of light, and turns that into a distance, a sphere. 4 overlapping spheres cross at a single point, you. The 4th also corrects your phone's imperfect clock against the perfect ones in orbit. The system even accounts for time running faster up there, exactly as Einstein said it would, and assisted GPS uses the internet to make it all happen in seconds. That's what's behind the little blue dot. Not a phone looking at the ground, but 4 clocks in space, the speed of light, and a 100-year-old piece of physics, all answering one quiet question: where exactly are you? Next time your phone finds you instantly, remember what it actually did. It timed 4 atomic clocks in space and let the speed of light draw the lines. This is Veyor, where we trace how the modern world actually reaches you. Next time, we leave the sky and follow your food. How you get fresh strawberries in the dead of winter. The astonishing journey that puts summer fruit on your table when there's snow on the ground. Subscribe, and we'll follow the next one together.